Hey guys, what's up people? Welcome to the session. Happy Sunday everyone. I hope that all of you guys are doing good and are excited for an amazing Sunday. I hope you guys have made plans for today. But nonetheless, studies should not stop. So here we are once again with the VIP series. Today we're going to be doing about light. But today we'll be talking about refractive index and refraction. So a little bit of refraction, but more about refractive index is what we're going to talk about. So welcome to the session. I hope that all of you guys are doing good and are doing, are preparing with your whole heart, for your final exams and your pre-boards as well. Good luck, all the very best, and I know that all of you guys would do really amazing if you guys just put in a little bit of effort. So don't become lazy now. Don't think that I have 5 months left. Please don't do that, people. You've already thought about that since the start of the year, and now here it's already Jan is about to end, so please don't do that. All right, so anyways, with that said, let's start with a very interesting quote, and the quote for today is this: determine your priorities and focus on them. And right now, every one of you guys, including us, our priority is to make sure that you guys are doing the best, and your priority should be to get the best. Do your best. It does not matter if your best is 70% or 80%, but give your best, so you don't have that regret that I could have done better. Don't do that, people. Right now you probably would have that regret, that why couldn't I start a little earlier. After 3 months from now, you should not feel the same thing. After 3 months from now, you should not feel that I should have started in the month of Jan or I should have started in the month of Feb. Don't have that regret. All right, focus on your goal, and your goal right now is to score your best. Do your best, all right, not what your neighbor's best is, not what your friend's best is. What is your best? Make sure that you do that, right? And that is my sincere wish from my side to all of you guys. So please make sure that you focus on that. Right now, that is the only thing that matters, right? So please make sure that you focus on that. So that's it, people. Let's begin the VIP series. But in the last session, I had given you a tiny little homework. This was the question, basically: if the radius of curvature of a convex lens is 40 centimeter, what would be its focal length? Such a easy peasy question. If you remember the formula, R is equal to 2F is the formula. Radius of curvature is given as 40, so 40 divided by 20 is equal to 2 is equal to F. So will be about 20 centimeter would be the answer. So these are the homework rockers who end up getting the right answer and was the fastest as well. We have Shubhankar followed by Ganesh, then it's Manaswini. Awesomely well done, you three. Then it's Gauri, Ganesh once again for the second time and then we have Divya Lakshmi as well. Divya Lakshmi, Yara. We have actually spoken to the team about the information technology wala thing. We'll see what we can do about it, right? So that is it, people. That is the homework rockers. Now again, if you want your name to be here in the next VIP series, make sure that you guys answer the homework question as fast as it is put up on the comment section, right? Anyways, with that said, let's move on to the first question. A series of 9 questions is what we have, so let's begin without wasting any more of our time. So the first question is from a sample paper. The question is this: refraction occurs because the speed of light is finite, the speed of light does not travel in a straight line, the speed of light has different values in different medium have different values of density. So why do you think refraction occurs? All right, 5, 4, 3, 2, 1. The answer, option number C. Why? Because it's very clear, people, when speed of light changes, the path of there'll be a slight bending of light happening. Again, the density is also different. Yes, that is also true. But then it is more because of the speed of light. The change in the value of the speed of light is different in different medium. Like in vacuum, it's 3 to 10 to the power of 8 meter per second. In air, it might be a little different. In glass, it's even more lesser. In water, it might be even lesser. No? So all of these, because of this difference in the speed of light in these different medium, that is why there's bending of light happening, and that is why refraction occurs, right? Moving on to the second question. Here is your second question, people. Given refractive indices of glass, diamond and water as 1.5, 2.42 and 1.33 respectively, in which medium does light travel the fastest and the light travels the slowest? Again, a sample paper wala question. Options are diamond and water, water and diamond, glass and diamond, or water and glass. So there are 3 refractive indexes given. One is of glass, one is of diamond, and the other is of water. Glass is 1.5, diamond is 2.42, and water is 1.33. Go ahead, people. Let me know what is the answer for this question. I'll give you 5 seconds. 4, 3, 2, 1. The answer is 1.33 would be the slowest, sorry, the fastest, because see guys, refractive index is inversely proportional to the speed of light. If the refractive index is more, if n is more, then the velocity of light will be less. It's indirectly proportional. If n is less, then the velocity of light is going to be more. So here, obviously, 1.33 is the smallest among the three. It's less than 1.5 as well, and that is the refractive index of water. So water would be where light would travel the fastest, and diamond would be where light would travel the slowest, because again, refractive index of diamond is 2.42, which is massive. Speed of light in diamond would be super slow because of that, right? So that is the answer, people. Good one. All those who got it right, congratulations, well done. If you did not get it right, it's okay. This is how you find it. All right, look at the value. Whichever has the highest value, that will have the slowest speed of light in that. Whichever has the lowest value will have the highest speed of light in that, right? Moving on to the third question. Here's another one. After passage through a rectangular glass slab, after light passing through a rectangular glass slab, a ray of light bends away from the normal, emerges parallel to and displaces laterally from direction of the incident ray. Emerges displays laterally but not parallel to the direction of the incident ray, or bends towards the normal. What do you think is the right answer for this one? After passage through a rectangular glass slab. Now I'm trying to recollect your rectangular glass slab, a ray of light passing through it. So what does it look like? Try to let me know what is the answer in the comment section if you are able to, or type it out, write it in a sheet of paper, or at least in your mind figure out what is the right answer, right? At least put it out in the chat box. Which do you think is the right answer? In 5, 4, 3, 2, 1. It will be option number 2, because yes, the emergent ray is going to be parallel to the incident ray, and yes, the emergent ray is going to be laterally shifted. It is going to move, it's going to move, it will be displaced laterally, not vertically, but laterally is the shift that is going to happen, and that is how the emergent ray would look like when the ray of light is passing through a rectangular glass slab. You already know this. It's not something that I have to say. You already know the answer for this one. So if you are confused, then this is the right answer, right? Moving on to the fourth question, guys. Here's another one. The refractive index of glass with respect to air is 1.5. Then the refractive index of air with respect to glass will be what? What an amazing question. Alright, so let me just solve this question for you guys. Do it with me, alright? Don't just sit there and watch me do it. Do it with me. It's a sample paper question. Could be asked in your board exams as well. So make sure that you do it. If refractive index of glass with respect to air, refractive index of glass with respect to air is given as 1.5. What would be refractive index of air with respect to glass? The answer, equal to 1 by refractive index of glass with respect to air. It's a reciprocal of that. So all you have to do is find the value of what is 1 by 1.5, because the refractive index of glass with respect to air is 1.5. So 1 divided by 1.5 would be 0.667. So that is the answer for this question. Such a jujube, such a laddu question, people, such a laddu question. All you have to do is find the reciprocal, and voila, that is the answer. So that will be the answer for the next question. It will be 0.667. So what you do is that you can, to remove the the decimal point, multiply with 10, numerator and the denominator. So it will be 10 by 15, which will be 2 by 3, which is nothing but 0.667, right? That's it. Simple. Another simple question. So yes, people, that would be the answer for this question. Moving on to the next one, the fifth question, halfway through. Here it is. The speed of light is in a transparent medium is 0.6 times that of its speed in vacuum. What is the refractive index of the medium? This is a CBSE 10th board exam question. Go ahead and answer this case. 1.5, 0.6, 1.67 or 2.5. Let me know what is the answer. Okay, so speed of light in a transparent medium is 0.6 times that of the speed of light in vacuum. What is the refractive index? Now, refractive index, that is the absolute refractive index. If you remember, absolute refractive index of a medium is equal to speed of light in vacuum divided by the speed of light in the medium. Speed of light in vacuum is 3 into 10 to the power of 8 meter per second. That's always going to be constant. So don't ever forget that. Speed of light in the transparent medium is 0.6 times the speed of light in the medium, that is in vacuum. So that is 0.6 into 3 into 10 to the power of 8. That is the speed of light in vacuum. So it's 0.6 times the speed of light in vacuum. So that's how you're going to get. Now, find it out. This gets cancelled because 3.3 to 10 to the power of 8, 3 to 10 to the power of 8 gets cancelled. So what you're left with is 1 by 0.6. So if you simplify this, 1, you can, again, 10 by 60 is what you're going to get. 0 gets cancelled, so 1 by 6. So the value would be, I think, it'll be, what is it? It'll be 1.67. All right. So 1.67 would be the answer for this question, right? I didn't want to go to the entire calculation. Yeah, so this is the answer. This will be the answer for this question. So the answer will be 1.67. That's it. Voila. That's another answer. That is the refractive index of the medium with respect to vacuum would be this one. Simple. Moving on to the 6th question, guys. So that's, the questions are pretty simple, so I don't think that you guys need a lot of time as well. But if in case you need a lot of time, make sure that you pause the video and try to answer this. Don't just sit with me and then watch the video. It's not it's not a movie that you guys sit and, like nod your head with me. No, do it so that you are able to, prepare yourself better to answer the questions as well, because ultimately in your board exams you can't just sit and nod, right? Your teacher is not going to know, your invigilator will not know whether you nodded your head or you nayed your head and all that. So make sure that you guys do it with me, right? Okay, here another question. 6th question. The refractive index of water and glass both with respect to air are 4 by 3 and 3 by 2 respectively. Find the refractive index of glass with respect to water. Is it 9 by 8, 8 by 9, 4 by 3 or 1 by 2? Another easy peasy question. Alright, first of all, refractive index of water is given as 4 by 3. Refractive index of glass is given as 3 by 2. What is the refractive index of glass with respect to water? So what is the refractive index of glass with respect to water? It will be nothing but refractive index of glass divided by refractive index of water. Simple. Refractive index of glass divided by refractive index of water. So it will be what? 3 by 2 divided by 4 by 3. So simplify this. So you'll get it as what? 3 into 3, this will go to the numerator, divided by 4 into 2, because that will come to the 2 will come to the denominator and 3 will go to the numerator. So you'll get as what? 3 3s are 9, 4 2s are 8. So 4 by 8 would be the answer to this question. Such an easy question, people. That's all. 4 9 by 8. Refractive index itself is such an easy topic, so make sure that you don't lose marks in this topic, people, because that'll be shame puppy shame. Now please don't do that, people. Please don't do that. Make sure that you guys practice a little, and that'll help you to score a lot better marks in your board exams as well. So people, let me ask you this question. Are you people enjoying the session so far? If you are, then give me a quick yes in the chat box, and more importantly, do not forget to hit the like button and subscribe to the channel. And yes, people, if you are enjoying the session and if you want to have more such amazing sessions just like this one and have a lot of fun and study about every single topic in detail, all you have to do is click on the link that is given in the description as well as in the pinned comment section. Now, let me tell you why. The link that you're going to click on will take you to the Vedantu website. Now, let me tell you why Vedantu is so amazing in helping you guys score better. First of all, we have time and again produced a lot of results. But how did we achieve that? Let me tell you that. We have unlimited live sessions. You can attend how many ever sessions you want. There is no limit to it. You want to attend 20 sessions, 30 sessions in a day, go ahead and do it. It's just like streaming on YouTube. You can watch how many ever sessions you want, and those sessions will 100% be fun, because yes, the sessions will be fun filled, and more importantly, there'll be a lot of quizzes in those sessions and leaderboards. And because of these quizzes and leaderboards, you can actually compete with the rest of the world and see how good you are in a particular subject, how good you are at physics, how good you are at chemistry, how good you are at social science. Every single subject you can actually compete with the rest of the world and see how good you are at something. And added to this, people, even if you miss out a session, don't worry, because even if you miss out a session, you can still take the quiz and still take the lead, check out the leaderboards as well. So you never miss out on the quiz. So you never miss out on practicing the questions over and over and over again. Even if you've attended a session right now and you feel like you want to take the quiz again and go through the recordings, you can still do that n number of times. How many ever number of times you want, you can do that. With this, you never miss out on any of the notes, any of the recordings, all the premium content, all the handwritten notes, all the recordings will be available to you in your dashboard itself. In the Vedantu dashboard itself, you'll be getting all of that. So you never, ever miss out on anything that is important, which was said in the class or which you feel like you need to refer to again. And added to this, people, I would say this is one of the best parts. You never walk out of the class with any doubts. You know why? Because with the master teacher, you will also have the class teacher to help you clear every single doubt of yours. If there's a particular class and there are like 500 doubts, all those 500 doubts will be cleared inside the class itself with the help of the class teacher and the master teacher. Right? So you never miss out on anything that is important, and more importantly, all your doubts will be cleared. And for all those who want to practice questions and do better, we have an unlimited number of tests and assignments available to you, people. So all these tests, so what will happen is that these tests are taken, the questions that are there in these tests are taken from your board exams, from your pre-boards, from your sample papers, from your Olympiads, from your NSOs, ISOs. So from all the important outlets, from all of those questions will be asked. So you don't have to go look around any place for sample papers or for practice questions, nothing. Everything is covered right here itself. With this, 5,000 plus micro courses and crash courses. Whenever you're bored, just walk into one of these micro courses and learn something new. Alright, people, link in the description as well as in the pinned comment section. My coupon code is AME Pro to avail the discount. So this is how it works, people. So the 1 month program is basically about 2,699. I know it's a lot of money, but then if you use the coupon code AME Pro, you get a flat discount of 500 rupees and the price drops down to 2,159. If you go for the 5-month program, that is until the month of June, that is Feb, March, April, May and June 21st until your exams will start, is set to start on June 14th, I believe, right? So even after your exams have started, we will be with you, people, to make sure that you guys are doing your very best. So do not worry. Before the exam, after the exam, will still be with you, people. So till June 21st, the course price is going to be of 7,200 rupees, including the coupon code AME Pro. Because if you think about it, if I just take it as 2,000 rupees alone for 1 month, for 5 months that's 10,000 rupees. 225 to 10,000, so 10, that'll be 10,000 rupees. If you use the coupon code AME Pro, you get a discount of more than 3,000 rupees, and what you're essentially paying is just 7,200 rupees for the next 5 months. Very valuable 5 months, if you ask me. Now you might be thinking, sir, what am I getting out of it? In that 1 month time, a minimum of 200 sessions you would have attended. That means per session you're paying about 11 rupees. And if you go for the 5-month program, you would have attended about 1,000 sessions in that 5 months, 200 sessions a month, which means in 5 months 10,000 sessions, which means that you would have paid about a 7.2 rupees per session. That is like super duper cheap, which is less than a packet of Lays that you pay 20 rupees for, right? So once again, guys, to enroll into the course, the link is given in the description. The seats are very limited, so make sure that you do it fast, because obviously it's filling up really fast because of your exams coming up soon. So make sure that you click on the link and use the coupon code AME Pro to avail your discounts, right? So that's it. Let's get back to the topic. Here is your 7th question. This is the last 2 questions are going to be a little big ones, but again, it's very simple. The question is this: with respect to air, the refractive index of ice is 1.31 and that of rock salt is 1.54. Calculate the refractive index of rock salt with respect to ice and the refractive index of ice with respect to rock salt? Again, it's pretty much the same question. I'm going to give you 5 seconds, pause the video and try to answer this question by yourself. In the meantime, let me try to solve this for you people. So yeah people, the refractive index of ice is given, refractive index of ice, I'll just write it as I, is given as 1.31. Refractive index of rock salt is given as 1.54. First of all, find out what is the refractive index of rock salt with respect to ice. So refractive index of rock salt with respect to refractive index of ice is equal to 1.31 divided by 1.54. So if you simplify the equation, you will get it as 1.18. Now again, I'm not getting the calculation, you can do it by yourself, but yes guys, you'll get it as 1.18. And for the second part of the question, where you have to find out the refractive index of ice with respect to rock salt, so Ni divided by Nr is equal to 1.31 divided by 1.54. you will get it as 0.8485, something like that, I believe. Yes, so that is the answer for that question people. It will be option number 3 or option number C, that is 1.18 and 0.85. Easy question, like such a bacha question now. And this could be asked probably for 3 mark, and maybe with this they might ask you to define refractive index, so maybe another additional 1 or 2 marks for that as well. So it's such an easy question. Please don't make mistakes, calculation mistakes, try to avoid it by solving as many questions as you possibly can, right? Last question people, after this we have one more homework as well, so don't leave, because if you want your name in the next session, make sure that you attend the homework question. Here's the last one. Velocity of light in a certain medium is 2 into 10 to the power of 8 meter per second, and velocity of light in air is 3 into 10 to the power of 8 meter per second. A ray of light is traveling in air, is incident on the interface of air and said medium at an angle of 30 degrees. With the interface, what is the value of sine of angle of refraction? Wow question. All right, option 0.33, 0.5, 0.87 or 0.65. Go ahead, try to answer this question. I'll give you 5 seconds. You have to try your best to answer the question. I'll also help you out to answer this, right? Anyways, let's do it. Now, velocity of light in a certain medium. All right, velocity of light in certain medium is given as, I'll just write as Vm is given as 2 into 10 to the power of 8 meter per second. They also give you the velocity of light in air, so Va is given as 3 into 10 to the power of 8 meter per second, right? So light is traveling from air into this medium, so from a rarer medium into a denser medium, so it will move towards the normal. So okay, maybe that looks almost like a straight line, but yeah people, you understand the point that it'll be moving towards the normal, so it'll look something like this. Yes, still, I mean almost straight, but you get the point people, it's going towards the normal, right? So that's how it is. Now the question is, what is the sine of angle of refraction? That's what they are asking you. All right, first of all, find out the refractive index. So refractive index of this medium, refractive index of the medium with respect to air is equal to the velocity of light in the air divided by the velocity of light in the medium. So that's how you find out the refractive index. So what is the refractive index? So it'll be 3 into 10 to the power of 8 divided by 2 into 10 to the power of 8, 10 to the power of 8, 10 to the power of 8 gets cancelled. So that's 3 by 2, which is nothing but 1.5 if I'm not wrong. 1.5 is the refractive index. Now that you find out the refractive index, use your Snell's law, use your second law of refraction to find out. So Snell's law, according to Snell's law, what is it? Refractive index is equal to sine I by sine R. Now sine I, though they've already given you, because the angle of incidence is given as 30 degrees, so that'll be what? So I'll just do it over here. So 1.5 is equal to sine 30 divided by sine R. So what is sine R? Sine R is equal to sine 30 is 1 by 2, which is nothing but 0.5. 0.5 divided by 1.5. So into 10 into 10. So that will be how much? It will be 5 divided by 15. 5 threes are 15, which is equal to 1 by 3, right? So 1 by 3 would be the answer for this question. So if you simplify this even further, you'll get the answer as 0.33. That is the answer for this question, people. And that is the last question as well. The last question was a bit of a dhamaka, but yes, it is rather a very interesting and amazing question. If they ask you this question, it's a clear 5-mark question. It's a clear 5-mark question. So please learn how to do this. Make sure that you practice the question. Make sure that you read your textbook. It's very important, guys. I can't stress how important reading your textbook is. Please don't ignore it. Please, it's a humble request from my side. Please don't ignore your textbooks. Super important. Once you've read your textbooks thoroughly, pretty much 90% of the topic is already done. You don't have to put in extra bit of effort for that. All you have to do is read your textbook thoroughly and make sure that you practice as many questions as you can. Now, you might feel a little lazy in practicing questions, so that's why I'll tell you, start with 2 questions a day. Start with 2 questions or even 5 questions. 5 physics questions or 5 numericals per day. Slowly increase that. For the first 2 weeks, make sure that you're at least doing at least 5 questions every day. 5 questions or one, start with light, then go on to electricity. Electricity, so you don't have much problems also. So light is the only thing that you have a lot of problems. So make sure you practice questions from there. Practice 5 questions. Take questions from your past year's question papers, from your sample papers, from whatever source you possibly can. Do as many questions as you can, guys, because I don't want any of you guys to lose your marks in those problems, because the formulas are it's very simple, direct substitution. So why lose marks? It's not like mathematics where you have to integrate and differentiate. Oh, it's rather simple mathematics, simple division, simple addition. So please don't lose marks on that, right? So anyways, guys, that's it from my side. This is your final question for the day, which will be a homework question. Do try this out and let me know what is the answer in the comment section. Let's see who gets it fastest. So the question is this: a ray of light falls normally on the surface of a transparent medium. What is the angle of refraction? My God, people, my God. If anyone gets this wrong, no, that's all. Alright, here's the question. A ray of light is falling normally on the surface of a transparent medium. What is the angle of refraction? Please don't get this wrong, people. Please don't get this wrong. That's it from my side. In the next session, the next episode, we'll be doing convex lenses problem. So I'll see you guys then. Take care of yourself. Until then, this is Anoop. Please make sure that you hit the like button and subscribe to the channel. I'll catch you guys in the next one. Until the next time, this is Anoop signing off for the day. Have a great evening ahead, people. Have a great Sunday. I'll catch you guys soon. Bye bye. See you all. Take care.